What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. And today we are back at it with our amazing SAT class. We are on SAT class 3 of 7, which is super exciting. So welcome, everybody. And if you have not joined yet, make sure to join our community on the school website, on the school platform. So let me just post that in the link one more time. I think I have posted it. It's in the description as well if you guys are having trouble finding out how to join our school community, but it's awesome and it's free. Everything is free. So there's the link. Make sure to click that on the school platform. Not only will you get the homework assignments and the entire schedule for this class from week to week, but you are also going to be able to you're also going to be able to access the slides, access, the video replays of the classes, all sorts of good stuff. So make sure to join there. Also, it can be a collaborative space. Some people are pairing up, teaming up, and making study groups. So that's all really, really awesome. All right. Now, today is a really important class because we are doing something where we're going into the second of 4 critical concept general categories. Okay, we're going into problem solving and data analysis. Okay, so this is a really big category, and we're going to cover each of the subcategories, which there are 10, and we're going to go through step by step. If you guys got questions, make sure to post them in the chat. I see Cole has said we're in slow mode. Yeah, we are. And but it's all good. You can post your questions in the chat, and we will go from there. And if you guys have any if you guys do like what you see as we're going along, make sure to click that like button. And if you do want to see more, make sure to click subscribe. Last but not least, if you're looking for extra practice materials, they do cost money, but it is an amazing resource, one that I partnered officially with. That's SATcrashcourse.com. Use the code SCALAR for 20% off. That's up at the top. You can see that link right there. So I highly recommend them. They are an amazing set of practice tests, really excellent in terms of getting you ready for the test. All right, without further ado, let's get into it. All right, so the first subcategory is ratios, rates, and proportions. So we're going to start talking about what are ratios, first of all. So ratios are comparisons of any numbers. One way of seeing a ratio is in fraction form, right? This would be a 1/2 or 1:2 ratio. We could also write it like this, 1:2. You could also say 1:2, like TO2. That's another way of expressing a ratio. Another example, 4/9 can be written as a 4:9 ratio, 2:5 ratio, and a 3:7 ratio. So sometimes they'll ask you to represent it as a fraction, other times in this format, and so on and so forth. It's a comparison. Now, when is this going to come into play, right? Let's say we're going in and we're saying for a classroom of boys and girls, there's a 1:2 ratio of boys to girls. What that means is for every 1 boy, there's 2 girls. So there could be 3 boys, 6 girls, 9 boys, 18 girls, so on and so forth. Okay. Now, when they say, sometimes we have questions like this. What is the ratio of A to B? Okay, and sometimes they might start us off with an equation. Now, these are really important questions because they're a little sneaky. You might look at this and say, well, there's 3 A's for every 7 B's. Okay, so the ratio of A to B is 3:7. And the reason why I gave this example is because this is one that is very important to flesh out. Now, remember, I said that A:B is similar to A/B. So a great way to tackle a problem like this is actually get it into A/B format. So for example, let's isolate A first. We're going to divide both sides by 3, knock those out. Now we've got A equals 7B/3. Now let's get that B to the other side. So we're going to divide both sides by B, cross it off there. And now we see that the ratio of A to B is 7/3, right? Or another way to say it, A to B is 7:3. Hope that makes sense, guys. All right. What's up, Abinette? Thank you for joining. Thank you, everybody, for joining. And thank you for everybody's participation in the class. It's been so much fun to just see people posting and sharing and liking stuff, and it's been excellent. So here we go. Now we're going to talk about rates, ratios, rates, and proportions. So what are we talking about? Rates. We're talking about something per something. And the best example of rates is distance equals rate times time, okay? So distance equals rate times time. This is our ultimate formula that we want to keep track of. And Lucy, can you shut this door for me? It's the ultimate formula that we want to keep track of when we're thinking about distance relative to rate relative to time. And I know it seems like a simple formula, but man, it really does help, especially with some of these complicated distance, rate, and time questions. So again, D stands for distance, R stands for rate, and T stands for time. Now, again, we're talking about rates. Once again, rate in this case would be like a speed, right? But it's always something per something. So again, our example is miles per hour. Or we could have something like dollars per pound. So we need to see that per word when we're talking about rates, all right? Now we're going to do a quick example where we're going to be talking about rates, all right? So it says, let's read this through. Laura can swim 2 laps in the local swimming pool every 1.5 minutes. 2 laps per 1.5 minutes. At this rate, how many minutes does Laura need to swim 12 laps? So I want you guys to think about this for a second, and as you think about it and come up with some ideas, I'm going to give you 30 seconds, and then we're going to show you how to do it. So go ahead. All right, guys, I am so sorry about that. Okay, so if you guys got some answers posted, that would be amazing. I'm so sorry, guys. Give me 1 second. All right. Louisa, can you take him? Guys, so sorry about that. All right, we're going to keep it going. Now, let's talk about how to solve something like this, right? We're going to use our formula distance equals rate times time, okay? And so what is our distance? Our distance is that 12 laps, okay? So we got the 12 laps and, to solve it, we'd say 12 equals our rate times 1.5. And then to continue solving, to isolate, we're going to divide by that time value, divide by 1.5. So 12 divided by 1.5 is going to, what is that? It's 8. Right? So it should be 8 laps in that case. Hold on, make sure I'm doing that right. Every 2 laps, every 1.5 minutes. So for 12 laps, I'm sorry, 9. Wait, I'm totally losing my train of thought. Sorry, all that barking got me mixed up a little bit here. Let me just write it out. So what we're gonna do in this case, right, is 2. We're trying to get a distance of 12, and we've got a rate of 2 laps per 1.5 minutes, right? And that's our rate. And then, I'm so sorry, guys. All right, so then we got the time here. And then we're basically dividing by this value. What did I say? 8, right? So to isolate, we're going to multiply by 1.5 and divide by 2. It's 9. My bad. So T is equal to 9. So it would be 9 minutes. Okay. So there we go. Yeah, that makes sense, right? 6 times 1.5 is 9. 6 times 2 is 12. All right. We are good there. Boom. Okay. Oops. All right, let's get rid of this. Let's keep it going. Here we go. Is it Dan's dog? No, Cole. That was not Dan's dog. That was my dog. And that was somebody else brought their dog in, and then my dog started going crazy. Okay, here we go. Now we're talking about proportions. Okay, so proportions are basically a fraction equaling a fraction. And these are really useful not only when you're given them in terms of how to solve them, but they're useful as a problem-solving tool, which I'm going to show you in one of our example problems down the line. So let's check this out. So A over B equals C over D. The way you're going to solve or simplify a proportion is via cross multiplication. You can see here, when we cross multiply, we get B times C equals A times D, okay? So another example, 1 over 3 is equal to X to 9, right? Again, to solve this, we're going to cross multiply. We're going to get 3X is equal to 1 times 9, which is 9. 3X is equal to 9. Divide both sides by 3, and you're left with X equals 3. Okay. Now let's move it along to proportions, okay? So talking about proportions here again in this example, we've got if 7 pounds of plums makes 8 fruit rolls, how many plums is needed to make 20 fruit rolls? Okay, first, think about it for a second. Post your answers in the chat. I'm going to give you guys about 45 seconds to think this through and begin. go ahead and post those answers. I see we got some answers coming in. Abinet, thank you. Now to give you guys about 20 more seconds. All right, here we go. So I'm going to show you now how to set this up and solve this using a proportion. We got two answers and they're both in agreement. So let's check this out. So here we go. We're going to set up our proportion. And when we set up a proportion, it's very important to label. I can't tell you how much easier this makes everything when you set up a label. So the top, and it's arbitrary. I could put rolls on top, plums on the bottom, but we're choosing something and we're sticking with it. So plums on top, rolls on the bottom. So we know we have 7 plums or pounds of plums to make 8 fruit rolls. And then the question is, how many pounds do we need to get 20? So you see the placement is based on the labeling. Now I don't have to think about, do I place on the numerator or the denominator? It's already done for me with the labeling. Now again, we're going to cross multiply like we saw before. So we get 8x equals 7 times 20, which is 140. Divide both sides by 8, and 140 divided by 8 ends up being 17.5, which is what both Cole and I believe Abinet also put, and Matthias. So well done, well done. And Hassan also got that right too. Osama Hassan, welcome. New subscriber. Thank you so much for joining. Okay, here we go. Now, moving along with another example. To make 4 batches of cupcakes requires 7 tablespoons of sugar. How many tablespoons is required for 5 batches? I'm going to pause, think it through, and post your answers in the chat. All right, we got some answers coming in. I see Abinet and Cole and Fortnite Sweaty Kid. It's a good name. Everybody seems to be, thank you for the likes. I see some hearts coming in. I see everybody's kind of in agreement here. All right, now let's see if you guys are correct. So check it out. Same thing. We're going to label the proportion. Very important to have this step. Batches over tablespoons. Again, that's arbitrary. And we know that 4 batches is required for, needs 7 tablespoons of sugar. So 5 batches needs how many? That's our unknown. That's our x. Now we're going to cross multiply, and we've got 35 is equal to 4 times x. Divide both sides by 4, and we are left with 8.75, which seems to be what everybody is getting. Cole, Abinet, Fortnite, Sweaty Kid, Matthias, Osama, all these people. So you guys are all rocking it out. Excellent, excellent. Okay. Now we're moving on to topic 2. You can see up in the upper left-hand corner. Now we're on to unit conversions. By the way, if you guys want specific practice with these subcategories, you can go into Khan Academy. That's where all these labels are found. Now, there is a little disconnect. I'm going to point it out when we get there for some of these subcategories and what I've been seeing on the new SAT from the College Board. Now, why is that? I want to explain that a little bit. The College Board and Khan Academy are not the same, right? They have a partnership, but the people at Khan Academy are not necessarily folks that work at College Board. So when they're coming up with practice problems or creating these categories, sometimes there's a little disconnect that I notice between the practice problems in Khan Academy and the Real Digital SAT practice materials. Always go with the Real Digital SAT practice materials as your go-to for your ultimate, most accurate source of material. And there are some things that are still in Khan Academy that I haven't seen on any of the new digital SAT practice problems. So I'm going to point that out when we get there. Anyways, all right. Now let's talk about unit conversions, okay? So we're talking about conversion ratios. So what's a conversion ratio? So it's our conversion of understanding, how many feet is in 1 mile or vice versa. But usually we're saying how many as the smaller unit goes into the bigger unit, right? So to convert 2 miles to feet, we take that conversion ratio. So again, 1 mile is equal to 5,280 feet. So we're going to place it in this order. Now, why did I put miles on the bottom and feet on the top? The reason why is because miles on the left is on the top. So I want it to be flipped. I want the miles to be on the bottom. This way, miles will cancel out and we're left with feet at the end. So we cancel those out. 2 times that, we get 10,560 feet. And there it is. Okay. Now we're going to do another example. Okay, we've got converting 3 days to minutes. So once again, what's our conversion ratio? Meaning, how many minutes are there in one day if we know that? But maybe we don't know it. So again, we can do this step by step, right? We can do multiple conversion ratios. Maybe first convert days to hours because that one we know. In one day, there's 24 hours. And again, days is on the bottom, so it cancels out with with the days on the left, right? Because it's on the top. Then we're going to go from hours to minutes. That's an easier conversion. We know that 1 hour has 60 minutes. And again, hours are going to cancel out because they're in opposite positions, one on the top, one on the bottom. Now we're left with just minutes. Now we just multiply across on the top, and we're left with our answer of 4,320 minutes. Okay. All right. Now we're going to move on to square or cubic units. So this is where it gets a little interesting. All right. So let's say now we're converting 2 square feet to inches squared, okay? You might think that, all right, well, 2 feet squared is the same as 12 inches squared, but that's actually not the case. The way you want to think about feet squared and inches squared is think, all right, well, 1 foot is equal to 12 inches. That's true. But when we square the units, we're also squaring those values in the proportion or the ratio. So now it's 1 squared, which is still 1, and 12 squared, which is 144, okay? So now 2 feet squared, if 1 foot squared is 144, 2 feet squared is 288 inches squared. Similarly, if we're talking about cubic units, and I added this in because the College Board has been testing this concept a lot, converting between regular inches, measure of distance, and then inches squared, right? Or inches cubed. So now if we talk about inches cubed, okay, we're converting 3 meters cubed to decimeters cubed. So again, the ratio of meters to decimeters is 1 to 10, okay? But what about meters cubed? Well, now we're cubing those values. What's 1 cubed? It's still 1. What's 10 cubed? It's 1,000. So now we can see that 3 meters cubed is actually 3,000 decimeters cubed. Cole says, do you see square feet to cubic feet questions? No, I have not. Great question. I have not seen that. That would be an interesting one. If you are doing, yeah, I've never seen it. But usually what you do is you go back to the original length and then you cube that. So for example, you would square root the square feet and then you'd get it back to feet and then you'd cube it, if that makes sense. Okay. Now we're going to go on to percentages or percents. All right. So what is percent actually even mean? Why did I break it up like this? Because this is the derivation of the word percent. Personne. It's a French word. And what percent literally translates to is per 100. Cent means 100. So therefore, 9% is 9 per 100. And if we represent this as a decimal, simply converting 9 over 100 to a decimal is 0.09. So another way to think about it is you are moving that decimal 2 spots to the left from 9 to 0.09. Likewise, 73% is 73 per 100 or out of 100. And that as a decimal is once again 0.73. 16%, same dealio, 16 out of 100 or 0.16. And 125% is 125 out of 100. Now this is going to be bigger than 1 as a decimal is 1.25, okay? So when we get to this point, the reason why it's important to see these decimal equivalents of percentages is because when we're making calculations or putting these in formulas, we're always putting the percent in decimal format. So that's important, right? If I want to take 73% of something, I'm not multiplying it by 73, I'm multiplying it by 0.73. Okay. Speaking of which, let's talk about the percent equation. This is how we calculate percents of things. So the percent equation is X percent times a total, right? We're taking it of a total is equal to the part. And again, that percentage is going in as its decimal equivalent. So for example, we say, what is 12% of 50? And again, you can do this in decimals or on your calculator. 12% of 50 would be my 12 in decimal format, which is 0.12. And how do we get that again? We move the decimal over 2 times. And so now we're at 0.12 times the total, which is 50. And that gives us our part. What is 0.12 of 50? That is 6. So 12% of 50 is 6. Boom, done. Okay. Another example. Now they might change it. They might say 9 is what percent of 45? Now we're solving for the percent. We're not solving for the whole part or the part. Okay, so when it's formatted this way, we use the same equation, right? And we're saying X percent of 45 is 9. That's the part. But the question is, what is x? Now we just isolate. Divide both sides by 45, right? And we get x is equal to 0.2. But now I want to know it's what percent. Now I have to convert the decimal back to the percent. So now I move the decimal 2 spots to the right. 1, 2, and we get 20%. Okay? So that's how you find an answer to something like this, where we're like, hey, what is the percent of, 9 is what percent of 45, 10 is what percent of 200, so on and so forth. Nice job, Aminette. Okay. We're going to go for one more example, another way that they can phrase it. 30 is 75% of what number? Now we're trying to find the total, the whole, okay? So again, we plug it in 75%, but in decimal format, 0.75, of what number is, right? My is as always equal, Cosmo, is, sorry for the dog barking. Uzi, can you grab? Is 30. Cosmo. I'll give it to you over here. Here you go. Okay. All right. So, sorry guys. Now to isolate, we're going to divide by 0.75 on both sides. Boom, boom, boom. Cross it off. And 30 divided by 0.75 is 40. Boom. All right. So that is how we do this one. Okay. Now, what about when they say a percentage increase versus a percentage of something? This word increase or decrease, okay, they're a little bit different. There's a little bit something extra that we have to take into consideration. Let's take an example here. Starting value of 1,200, and we want a 20% increase. We're not trying to find 20% of 1,200. Well, we are, but an increase means we find 20% and then we add it back onto the original. So what is 20% of 1,200, right? Oh, sorry. The way that I'm showing you here is how we're going to change this percentage value, right? So a 20% increase, we now have 120%, right? 100% plus that 20%. So we're talking 120% of this 1,200. So now we convert this into its decimal equivalent, which becomes 1.2, and we multiply this times 1,200 to get 1,440. Now, the other way we can do this as well, if this is easier for you conceptually, is you find 20%, which is 240, and you add it on to 1,200. It's important because what if we said an increase of 150%, right? Just like the same thing here, that means we're actually finding 250% as opposed to 150%. So it's that word increase that changes the game a little bit. Okay, good job. Now moving on to percentage decrease, okay? So it's the same idea. We have the starting value and then we're decreasing by this 1,200, okay? Or by this 35%. All right, so what we're going to do is we're going to calculate 35% and remove it. Or the other way that I'm going to show you is we're going to take 35% away from this 100. So we're taking 100 minus 35, and now we're left with 65%, okay? Now, again, convert it back to its decimal equivalent. 65% or 0.65 of 1,200 is going to be our value here, which is 780. Again, the other way we could have done this is calculated 35% of 1,200, which would be 420, and subtract it. But that's two ways to get to this answer. Hope that makes sense. All right, boom, done. All right, moving on to number 4, center spread and shape of distributions is the 4th subcategory. Okay, here we go. So when we're talking about center spread and shape of distributions, the main things that we want to be familiar with are when we have a data set, how might we calculate the mean, the median, the mode, and also the range. Okay, so let's talk about that with this data set. So we have a bunch of numbers here, 1, 2, 3s, 4s, 5s, 7s, 8s, and 9s. So if we're talking about these different values, now we're going to go through and we're going to say, first of all, how would we calculate the mean? What is the mean? And remember, there's a mean function in Desmos that we can use where we type mean parentheses and we just type in the values and we'll calculate it for us. But what we're doing with mean is, yes, Osama says it is easier to use Desmos for percent. Absolutely. But still, you got to know what to do, what you're multiplying. Actually, you can say 5% of something. That also works, by the way. But this is how you would do it just straight numerically. Now, the mean, you're adding everything up, and then you're dividing by the number of items that there are. So since there's 13 items in this data set, you're dividing by 13. Okay? And here we would get 5. What's mode? Mode is the number that we see the most of. Hence, in green, we see 3 3s. That's the most of any other number. Hence, our mode, the number we see most frequently, is 3. Okay. Now we get to median. What does median sound like? Middle. Okay, median is the middle value, and that's when it's arranged from least to greatest, as we have here, and that exact middle value, which is 4. Now, if there happens to be an even number of items, now we're going to have like 2 middles. Right here, there's 13, so it's an odd number. But if we have 12, for example, the 6th value and the 7th value are technically sharing the middle space. In that case, to get the median, you take the average of those 2 values. And last but not least, we got range. Range is going to be the difference of the greatest and the least value, 9 and 1. 9 minus 1 gives us a range of 8. That's how you do it. Okay. Now, another thing that I've seen being tested a little bit less on, actually, I don't even know if it's been tested much at all on the new version of the digital SAT, though they used to test it all the time, is standard deviation. So I'm just going to explain what standard deviation is conceptually. We never had to calculate it explicitly on the SAT, but you had to have an understanding of it. So for example, standard deviation is the measure of spread of data. How more spread out it is, the bigger it is. The more tightly packed the data is, the smaller the standard deviation. So for example, okay, and Cole's saying, in the College Board Practice Bank, came across a question where you need to know if a graph has symmetric distribution. Yeah, okay. So if we'll talk about symmetry in a second, actually. That's a great question. So I can explain that. But when we're talking about standard deviation, let's show a larger standard deviation, which 5, 6, 7, 8, 9. Look at the distribution. It's all spread out. So there's a big spread. It's spread across 5, 6, 7, 8, 9 pretty evenly. Versus a smaller standard deviation, look how more tightly compact the data is, all at 6s and 7s. So really what we're talking about is how to distinguish between a larger and a smaller standard deviation. Now, if they both have the exact same spread, now we're talking about equal standard deviation, but that's the gist of it. Okay. Now, and by the way, if we're talking about symmetry, if I just go back to this, like this is actually right here a symmetric data flow, right? We have 6s and 7s kind of right in the middle. But if we had symmetry beyond that, let's say we had 5s and 8s, I'd want to have the same. Actually, this is technically kind of symmetric as well, but we'd have 5B3 and 8B3, right? So it's going out to the left and the right. We have perfect levels that are kind of like mirroring each other as we go left and right. Okay. All right, now here's another type of way that you're going to measure center shape and distributions as well. And this is something called a box and whisker plot. So a box and whisker plot looks like this. And we're going to kind of go through all these different pieces of a box and whisker plot just so you can understand how to interpret it. So for example, first, the left end is the minimum. The right side in blue is your maximum value. So here you see the minimum is 2, the max is 10. Now we have this center line. This is probably the most important line, most commonly tested item here, which is the median. Now somebody asks you, what's the mean based on a box and whisker plot? You cannot answer that. It's not presented in the box and whisker plot, nor is the mode. Only the median, which is that middle value. Next, we have that value in orange, which is called, this is much less likely to be tested, but could be. That is our lower quartile value. We've got in green the upper quartile value. Now we got 2 other things to note. We've got something called, well, the range, which is the max minus the min, which is always the case, 10 minus 2, which is 8. And we've got the interquartile range. Again, not likely to be tested, but that is the upper quartile minus the lower quartile, 8 minus 4, which is 4, boom, done. Okay, now we move on to data representation. So what are data representation types of problems? A lot of times you're going to look at data in a graph format or different ways, and you're going to see if you can interpret it correctly. Now, when we think about different linear relationships, right? First, we're going to talk about slope. That's one element. When it's positive, it's an increasing situation, where as we go to the right, we're going up and up and up. When we have a negative slope, we're talking about decreasing as we go to the right as the values of x increase. Our y-intercept is our initial value, which are those green dots right there. And our x-intercept, which is the point of no value, depending on the concept of the problem, it could be when profit goes to 0 or when, whatever metric you're measuring on the y-axis, whenever that goes to 0, that's the x-intercept, which is marked in purple like that. And if we have another example of a nonlinear function, we can still look at slope as increasing, right, where it's going up to the right, decreasing where it's going down to the right. We've got our y-intercept, same thing, that's still our initial value. And we also have our x-intercepts, which are the points of no value. And for this function, we actually would technically have two, right? We'd have one here as well as one there, but I only highlighted the positive one. And for this particular example of vertex, that's your min or max for a quadratic in particular. You don't have that in a linear function. In this one, it would be the maximum value, whatever we're measuring. But let me put this in context, okay? So check this out. Zane likes to go rock climbing, the elevation relative to the peak of the mountains, blah, blah, blah. Time in seconds is labeled. At what speed in meters per second did Zane climb during the last final 350 seconds of his climb? Okay, I'm going to give you guys 30 seconds. Let's say 40 seconds. See if you can answer this. Put your answers in the chat. Take it away. Feel free to post those answers, guys. I'm going to give you guys 10 more seconds. Okay, we've got a couple of answers, and they do seem to be matching up. Now we're going to see. Okay. All right. So what are we talking about? We're talking about speed in meters per second. What do we say slope was? That's a rate. What do we say rates are? Something per something. So that's our indication that we need to find the slope. So what is the slope? Well, we got a rise of 25. We've got a run of 350. So now that means we've got 25 over 350. As we simplify that, we get down to 1 over 14. Now, the answers that we got are 0.07, which I believe is an approximation of 1 divided by 14. Whoops, let me double check. And it is, yeah, you guys are right on. So you guys were feeling like that was incorrect, maybe because you had to round, I suppose, but that was right on the money. Now, I entered it as 1 over 14 just because I like the fractions. I don't have to round, and it makes me feel more comfortable. But great work, everybody. Good job. You guys are killing it. All right, let's move along. Now, what if we have a question talking about the x-intercept? All right, let's check this out. The graph in the XP plane represents a relationship between the number of pairs of jeans that the manager in the department stocks the season and their profit in dollars. What is the best interpretation of the x-intercepts? And we've got these different options. By the way, I don't know why A is in blue. That doesn't mean that A is right. But anyways, take 40 seconds, give it a shot, and let's check it out. Make sure to post those answers in the chat. Cole said the 0.07 felt wrong because it felt really, really small. Yeah, that makes sense. I mean, it's not that small if you think about it. 0.07 meters, what is that? 7 centimeters, right, per second. I mean, it's not that slow. Okay, we got an answer from Cole. Cole, why don't you put in the, I know which number or which letter you're referring to, but why don't you put the letter in that you're referring to as well? Okay, thank you, Cole. Okay, so let's now talk about it. So let's go into this, right? It's asking about the x-intercepts, which occur right here, right, where it's hitting the x-axis. And what's happening at the x-axis? It's when the y value is hitting 0, meaning, in this case, when the profit is 0. But none of this says when the profit is 0. But the best thing that we can find here, and I don't think they'll do this to you on the actual SAT. Again, this is from Khan Academy, so I don't think they're going to say break even because it might confuse people, I think. But the break even means that's when your profit is equal to 0, meaning your revenue equals your cost. So that's why. So D is correct. Abinet and Cole, great job. Good work. Let's move it along. By the way, if you guys could give this video a like if you haven't done so yet, would really, really appreciate it. All the likes help tremendously. So that would be terrific. All right. Now we have a y-intercept problem. Once again, go ahead and give this a shot. It says approximately how many pounds would Aiden weigh on the surface of Mars? Take 30 seconds and think it through. Post those answers in the chat, guys. And again, you can approximate here. It doesn't have to be exactly right. Okay, we got some answers coming in. Cole and Abinet, amazing. Let's check it out. So again, we're talking about the surface of Mars. Well, what does that mean, right? We have to interpret that. Well, this is the altitude above the surface. This is 200 above, 400 above, 600 above. But at the surface would be how much? 0 above, meaning right here. Meaning, this is talking about our y, or in this case, w-intercept. So it's right there. And what does that looks approximately? We got 57, we got 60. The answer they gave was 57. Again, they're not going to give you something like this vague. You're going to be able to see definitively that it's 57, 58, 56, whatever. So, but that's the gist of it. That's how you interpret it. And that's what it all comes down to. All right, moving on to topic 6 of 10, scatterplots. And in particular, we're going to talk about lines of best fit. So what is a line of best fit? It is this line that you're going to string through a bunch of data points, okay? And then you're going to answer questions theoretically based on this line of best fit. Sometimes they will provide it like they did here. Sometimes you're going to have to draw it in or imagine it. So in this case, they're asking which of the following statements is true regarding the trend line, aka the line of best fit. Go ahead, think it through, give me an answer, and then we're going to talk about it. Take 30 seconds. All right, we got some answers coming in, or at least we got one from Cole. Give you guys 10 more seconds. Okay, so the answer is B. And this is a statement of slope. 1 million every 5 days or per 5 days. How did they get there? They're talking about slope, right? And we can see it with these are really two nice points here on this line of best fit, right? We're going down by 4 million and we're going over by about 20 days. So 4 million per 20 days or 1 million per 5 days. That's the slope. That's how you do it. Boom. Okay. Now let's do another example where we've got this graph and we have to draw something in, right? So anyways, the question here is with this line of best fit that we've drawn in, okay, which one of these models this correctly? So this is what I'm going to just kind of talk about. First of all, is this linear or nonlinear? definitely nonlinear, right? That's curved. So A and B are out because those are our linear options. Now the question is whether it's C or D. Again, you got Desmos, you got calculators, you can plug and chug and see which one makes sense, right? Which one are you going to plug in 2 and get 32? Which one are you going to plug in 1 and get 64? But I'll tell you this, you can even jump to the answer more quickly because when it's going out like this, basically down to the right, the value in the parentheses has to be less than 1. It can't be greater than 1. Hence, C is going to be your answer. But again, you can see like you can just plug and chug, plug in 4, and you're going to get 8. Plug in 6, and you're going to get 2, so on and so forth. Here, if you plug in, I don't even know, let's say plug in 2, you're going to get some massive number, right? Not 32. You're going to get 2 squared, which is 4 times that, which is 480 plus 512, I think. So totally wrong. Topic number 7. Linear and exponential growth. So you guys are familiar. We just looked at an exponential function in the last one, and we've been looking at a lot of linear functions as well. What's the general difference when we're looking at linear versus exponential in a table? So if I've got the x's going up by a consistent rate, which is 1, 1, 1, right? The y's should be going up by the same amount every time, and they are, right? X goes up by 1, y goes up by 3. Boom, boom, boom. Slope of 3. Exponential is a little different, right? We have a multiplier usually. So in this case now, as x goes up by a consistent amount, 1, 1, 1, what are we doing? Are we adding the same amount? No, we are not. We are multiplying, right? We're multiplying by 2, doubling, 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 doubling. It doesn't always have to be a whole number. It could be multiplying by 1.5, or it could be bigger than 2. It could be 3, it could be 4, tripling, quadrupling, etc. So this is the difference. This is how we can identify between a linear and exponential model. So now some graphs and examples of linear, right? We've got 2 different examples, one with a positive, one with a negative slope, and that's what they look like, and they're just straight up lines, versus our exponential. Again, this is exponential growth, where the value in the parentheses, as I mentioned, is greater than 1. And then we got exponential decay, where it's less than 1. For growth, it's growing by 20% on the top, increasing by 20%. On the bottom, it's decreasing by what we're subtracting from 1, which is 30%, right? And that also makes sense because 0.7 is 70%. If we're retaining 70%, that means we're losing or decreasing by 30% as we go along. Okay, topic number 8 out of 10. Probability and relative frequency. Okay, so let's talk about this in terms of some tables. So when we're talking about probability, let's take an example here. We say, what fraction of students surveyed take math? Okay, so this is a kind of our most basic level. I want you guys to take 30 seconds, see if you can give me the fraction. Don't even have to simplify it. What fraction of students surveyed, all the students surveyed, take math? You can simplify it if you want. You don't have to. Write it in the chat. Take it away. Okay, Cole, we got some answers coming in. That's phenomenal. Going to give you guys 10 more seconds. Abinet, I don't know why, has also posted something. All right, now, Cole, I did see your initial message or your initial answer. I'm not going to call it out, but I know you've retracted it and updated it. And I know why well, anyways, let's talk about what is the correct answer first. So fraction of students surveyed, all the students. I think Cole initially had 130 on the denominator, but that's the total of science. And I think he figured that out and he changed it to 200. So the total is 70 plus 130, and the amount of students that took math alone is in that math column, 70. Hence, we get 70 out of 200. Now, we could reduce that to 7 out of 20 if you wanted to, right? But I was asking just the straight up fraction. That's fine. 70 out of 200, boom, done. Okay. Now, what about this question? Of the females surveyed, what fraction of students surveyed take science? Okay. Hit that pause button and think it through. I'll give you guys about 30 seconds, and then we'll jump back. Okay, we're going to jump in 10 seconds. Okay, so this is conditional probability of the females surveyed. What does that mean? That means that we are strictly in this column. That's it, okay? So we've got of the females, which is 46 plus 58, which is 104. How many take science? That's 58 out of the 46 plus 58, which is 58 out of 104. I don't know why I had the correct answer, as did Cole. Amazing. Boom, done. All right, that is our conditional probability. Okay, let's move it along. Here we go. Of the students who like math, what fraction of students surveyed are male? Of the students who like math. So again, we are in this column, right? Just of math. What fraction of students surveyed are male? So in this column, that'd be 24 are male out of a total of, which it gives us right there, 70, right? 24 out of 70, which Cole put down. That is correct. That's how you do it. All right, moving along. Now we have one more problem from Khan Academy, which is pretty cool, and I'm just going to highlight the key parts here. What are they asking about? They're asking about products that are both polycarbonate products and that contain BPA. So what two columns are they talking about for an intersection here? They're talking about polycarbonate and contains BPA, which is this value right there, 258. Those are the amount that contain both of those. And that's the percent of everything. What's the everything? That's our 499, which means we're 258 out of 499. When you calculate that as a percent, meaning divide 258 by 499, you get, well, you have to multiply by 100, but you get 51.7%. Okay, so again, with these frequency questions, we're looking at the tables. It's just very important to read it carefully so you know exactly what should be your total, what should be your part, so on and so forth. All right. Now we're moving on to topic number 9. Cole, nice job with the 0.517. I just put in percent format. You put it in decimal format, but that is excellent. All right, data inferences. The key with these questions in general is quite simple. Careful reading of graphs, data, and question prompts. So just make sure that you're reading everything carefully. You're not missing any details. So for example, oh yeah, by the way, and one of the things that's tested a lot in this area is margin of error. What is margin of error? Let's give an example. Let's say we say 72 with a margin of error of 5. Well, what does that mean? That means the range of possible values that are going to be probable is going to be 72 minus 5 and 72 plus 5, which means now the margin of error tells us we can be from anywhere from 67 to 77 for a plausible value. Doesn't mean the value of whatever we're talking about, whether it's a mean value or whatnot, has to be between 67 and 77, but it's highly probable that that is the case. Okay, let's take an example here. We have a mean gas mileage of 25.9 with a margin of error of 2.6. Now, I see that they put the confidence level. This is something that they used to test a lot, confidence level, on the old SAT. I haven't seen it once on the new digital SAT. That's why I'm not going over confidence level. I don't think it's going to be tested on anytime soon. But go ahead and think about this and post your answer in the chat, and then we'll go through it. Take 30 seconds. Okay, we got some answers coming in. Ooh, Cole, I love that comment. Make a story about the chart before reading answers. Yeah, 100%. I love that. Actually, I always do that too. I don't know if I call it making a story, but I always make sure to get my head around what are the axes saying, what's the graph saying, and then go into the question. Really get a good understanding. Great. Okay, so I'm going to say that Abinet is correct. Why is Abinet correct? Because if we have a 2.6 margin of error, that means we're going from 25.9 minus that to 25.9 plus that, which means our range of plausible values is 23.3 to 28.5. The only one that falls in that range is 24. Okay, we got another question here. And this one I'm going to walk through with you guys. This one's Pretty interesting, but pretty tricky. So here are all the important tidbits as we go through it. So the first thing is, what are we trying to find? We're trying to approximate the number of students who prefer walking to class. And in our chart, okay, as Cole mentioned, we should understand it. In our chart, we have number of students and their preference of driving, biking, walking, and other. And so we see right off the bat, we have 18 students that prefer walking. Yeah, but it's 18 out of what? We could add them all up, but they actually gave it to us right there. So again, reading the prompt carefully is helpful here. So we know we're 18 out of 40 as our percent or fraction of students who like walking. But we want this fraction of the total number of students, which is 6,000. So we need to take this fraction of this total to get our answer. And what is 18 over 40 times 6,000? It is 2,700. That's how you do it, okay? Hey, Cole, nice job with the answer. So again, piece it together. Make sure you understand the data. Make sure you understand the chart. Make sure you know how to apply it to what they're asking in the total. That's how you do it, all right? Another sample question. So let's step it through, right? We've got 10% of citizens said that, or sorry, of these 10% of citizens, 7 said that Energize was their favorite coffee shop. And we need to now say, based on this, how can we apply this to the entire population? Great way to do this. We're going back. Remember I said we had a nice proportion example? Here's our proportion example of how to solve this. So check this out. We know that if we split this up as percent as it relates to people, we know that 10% of the population gave us 7 people that said Energize was their favorite coffee shop. So I need to know now, if we have 100%, the entire population, what is the amount of people? Now we got our proportion. If you guys remember correctly, we are going to cross multiply as follows. 7 times 100 is 700 equals 10 times x. Divide both sides by 10. Boom, boom. And we get x is equal to 70, which means D is the winner. Boom, done. Nice job, Abinet. All right, we are on our final category. Now, before we get into it, let me give you this caveat. I have not seen any of these problems that used to occur in the old SAT on the new digital SAT. I just haven't seen it. So I don't even know if this is a super important category, but we're going to go over it nonetheless because it is one that is listed by Khan Academy. And once again, why is it listed on Khan Academy if we're not seeing it on the College Board? Because sometimes there is a slight disconnect. So just be mindful of that. But let's get into it. So the main things that we have to remember when we're evaluating statistical claims is, like, if we've taken a sample and we're trying to apply it to a set group of people, we can only apply it to the population that was sampled. So for example, we've got this whole thing and we're trying to answer how does this survey, we got 55% preferred mango, 20% preferred papaya, and 25% preferred coconut. Who can we apply this to? Well, we got to go back to the sample. Who did we sample? All customers at their store. So now read through the answer choices, give you guys 30 seconds. Tell me which one do you think is the correct answer? Go for it. Okay, and by the way, I do want to say this type of question in particular of applying the results to the original population is more likely than what we're going to go through on the next slides. But anyways, just giving you that caveat. I haven't seen a ton of these. So which one of these applies? And I think we see that Abinet is answering. Oh, Abinet's answering A. Cole is answering C. Yeah, okay, well, we're going to see. So Abinet, you're saying A. Most people in the world, that's a pretty big population to apply this to when they're only sampling customers from their customer base, right? So I'm going to say that I'm going to disagree with A, and I'm going to agree with Cole. And Cole is saying C. 55% of all customers who shopped during the sampling period, okay? That's our best answer. You could probably apply it a little bit more broadly to all of their customers if you said, hey, we took a random sampling of customers. But the problem is they took a random sampling within a particular time frame, okay? So during the sampling period. So you can really only apply this to those folks that were sampled, that general population that was sampled, which was the population that was in the store at that time. I hope that made sense, guys. Okay. Now, let's move it along to another thing we want to look out for in data collection in particular, which is looking for inherent biases in sampling, because a lot of times this can discredit an entire survey or sampling study, whatnot. So we want to look for biases in two main places, which is location as well as preferences. So preferences is a little broad to define, so let me give you an example. A school district wants to conduct a sample to survey the average number of sports played by high school seniors in the district. Which of the following is most likely to produce valid results? Well, let's talk about the ones that are problematic. Okay, so first of all, this one. The district surveys 500 randomly, I like the word random, randomly selected high school seniors in the district who play baseball. Well, we're trying to figure out the average number of sports played by high school seniors. You're already having a problem because you're already limiting it to people who obviously at least play one sport. Okay, there might be a lot of students that don't play any sports. There might be some students that play 10 sports but don't play baseball. So by kind of drilling or building this preference into the population, it's not really a random sample. So this is a bias that's going to taint this entire sampling and survey. The district surveys every 10th student to, again, location, enter the football stadium. Problem, right? Because there's probably some inherent bias for people who like sports, right? One other example that is biased based on location. Why are you selecting one district? Now we're not trying to. That we're not getting a large enough sample that's going to be representative of the entire district. So, of course, C is the answer, where 500 randomly selected high school seniors in the district. Now we can apply it to the district. Now there's no biases. We're good to go. Okay, one more example. Here we go. So near the end of a local talk show, the host invited listeners to respond to a poll on the show's website. Are you in favor? Boop, boop, boop. Okay. Which best explains why the results are unlikely, meaning unlikely to represent the sentiments of the local population, meaning where's the bias? Well, wait a minute. This is a particular talk show, okay? So we're already limiting it down by the people that are watching the show. Maybe it's mostly like people with a particular political leaning that watch the show, or whatever it may be, a younger audience, a older audience, who knows, right? But this is the bias on the website who watched the show. Therefore, those who responded to the poll were not a random sample. We don't know what the biases might be, which way they might make people lean, but we know that they're biases because it's not a true random sample. You're already tainting it because it's only people who watch the show. Okay. All right, that is it for our presentation. Osama says he's back. Welcome back. Thank you for joining. And if you missed some of the stuff, you can always rewind and rewatch. This is going to be up on YouTube so you guys can watch the replay. I just want to say thank you guys so much, everybody, for joining. We are done with class 3 of 7. This is super exciting. If you haven't joined our school community yet, I'm going to post it in the chat right now, our link, but it's also in the description below if you want to click on it. But here is the link. Make sure to join if you haven't yet. This is where you can get all these materials, practice problems, the calendar, the schedule, everything like that. So join our school community. It's growing and growing. We have over 200 members and growing strong, so it's pretty exciting. And for those of you guys who are following along and really trying to do your best and showed up right on time, I really appreciate it. Thank you for participating and asking questions. If there's anything else that you think is missing from the school community or other things that you want to see in the class, make sure to post those in the comments as well. Or if you're seeing in the live chat, post it there. If you're seeing in the comments after the fact, post them there. We're continuously trying to improve, post more practice problems and all that good stuff to get you guys as ready as possible for this upcoming SAT. All right, guys. Geometry and trigonometry is not next week, but it's the week after. Thank you guys so much for joining. Oh, Cole said a quick question. Do you think the math section of August is going to be very different from June? I have no clue because the College Board isn't releasing much information, but there's probably going to be a lot of similarities in general across the board from test to test. Is it going to be massively different? It's so tough to answer. They're not even releasing anything. I still haven't even seen the June or any of these other previously administered SATs. So your guess is as good as mine in that specific sense, but in a general sense, there's always going to be large chunks of similarity from one test to the next. Okay, guys, I will definitely make an August prediction video. Thank you guys so much for joining. For new subscribers, thank you for subscribing, for all the likes. We appreciate it. Thank you guys so much, and I will see you in the next video.